I guess I'll start with education. I did my undergrad at Swarthmore College, which is a kind of small liberal arts school with an engineering program. It's a combination I certainly recommend. And then after that, did my master's at Johns Hopkins uh, before returning to New York, which is my hometown, where I worked as a structural engineer for about 8 years. Did the first half of that at a company that did a lot of kind of private work, commercial office buildings, residential. And then the second half was at a company that did a lot more kind of institutional work for the various New York City transit agencies and state, I guess, offices and universities, that sort of thing. So um, kind of seen both sides of the industry in that sense.
And how'd you end up in Japan? You're in Tokyo right now.
Yeah. Well, I guess at the end of that 8 year period in New York, my wife got a good job offer over here in Tokyo, and so we figured we'd give it a shot. Came over, which was a bit, I guess, bittersweet for me, just in the sense that for a structural engineer who really enjoyed uh, what he was doing at the time. There are not a lot of prospects here in Tokyo, just because, unlike a lot of countries, there's a really well-established engineering community here. So, yeah, and obviously it does its work in Japanese, which is not something I'm fluent in. So there was kind of a period there where there wasn't too much happening aside from just taking language classes and a lot of parenting. Um, but opened up some new. It certainly was an opportunity to see a lot of new things in terms of different ways to do construction that kind of I hadn't anticipated. So
What is your background and expertise in HSS in particular?
honestly, I'm not sure that I have, at least from a background standpoint, all that much expertise beyond what you would expect for a normal structural engineer with a few years of experience. Certainly, while I was working in New York, I used it in projects, and but I don't think really focused on it in any particular way. And certainly now that I am working for a company, obviously that produces HSS, and I've had a lot more exposure to it, I kind of realize there are some things, uh, some best practices maybe as an engineer that I wasn't aware of at the time. So it gives me maybe a bit more perspective on things that we need to work on educating the industry about.
So, if our audience doesn't know, you invented Shuriken. What inspired you to invent and develop Shuriken, and how did you go about doing that? I'm really curious about your process there.
Yeah, so I don't know if you can see behind me, there's actually a photo here that I took of some steel construction here in Japan. And one of the things that really surprised me when I came over here was just how differently they did a lot of things in construction. I had kind of figured that steel is the same and concrete is the same, so engineering and construction would also be the same. And I hadn't really understood the extent to which I had just assumed that the way we did things in the States was the way things were done everywhere. And that turns out not to be the case. And so one of the big differences that you see in Japanese construction versus American construction is that in buildings, about at least 99% of columns here, at least in steel buildings, are HSS, or if it's too big for that, there'll be a built-up box, which is very different from the US, where the vast majority of the columns that we use are wide flange shapes. Um, and you know, in seeing this, I sort of thought, wow, this is great. Using hollow sections means there's a lot less tonnage that goes into the building. And whether you're just concerned about cost or you want to reduce the carbon intensity of construction, uh, using less steel is obviously a good thing. And so I kind of thought, is there a way that we could kind of bring this practice back to the States and start using more HSS in our steel buildings? The problem was that uh, anytime you have something taller than what you can deliver on a truck, you have to splice the columns. And here in Japan, the standard way of doing that is a field welded column splice. And if that's the only way you can do it, there was basically no chance it was going to catch on in the States. It's just much too labor intensive of a process. And so that was kind of the trigger that got me thinking, well, is there a way that you could get the benefits of the HSS columns, but do it with a bolted connection? And that was, led gradually to the development of Shuriken to serve that purpose.
Can you talk a little bit just about the process of trying to invent something that knew that it hadn't existed before? I'm just curious how you went about that.
It was more about realizing the need, the problem, rather than having a specific idea for how to solve it. Um, Once I realized that that would be a useful thing to have, I kind of uh, you kind of start with a lot of bad ideas, and as you eliminate those and gradually you know figure out what the issues are and how to improve them, um, it's a kind of just a slow process that gets you to something usable. I mean, it started out with something that a steel fabricator could fabricate in their shop out of steel plate. That works, but it's very expensive. And then it became, well, what if it's a steel casting? That's a little bit better, but still probably too expensive, for wide adoption. And eventually that developed into a Shuriken. But I think, honestly, one of the most important things was just the fact that, not working as an engineer at the time, I had a lot of available time to think about things. I think it's not hard to come up with a good idea, but so often in life we have a lot of things that are kind of pressing, whether it's work or otherwise, and we think about it and we say, well, that would be neat, but then don't have the opportunity to follow it up. So the idea, and then just having the opportunity to really kind of you know focus on it over a long period, I think was the key.
Okay, before we talk about Shuriken a bit more, I want to get to that. But as far as I'm still talking the inventing process. If let's say someone has a good idea, but yet they don't have the time, you got some advice for them and on ways they can still go about trying to create their goal or their dream here?
Well, I'm not sure I can say specifically from experience, but I guess if you really think it's a worthwhile idea, that should be pursued, it may just be a matter of setting aside, whether it's an hour a week or 20 minutes a day or whatever you can kind of you can manage, to think about it. I mean, for me, from initial idea to kind of a workable product was about a year. So even if I guess even if you did have more, more things that you had to take care of, you could still do it in, who knows, 2 or 3. So yeah, I mean, it's, I guess, just be persistent, because most of that time will be spent with your best idea so far being not good enough, right? It's only when you get towards the very end where you finally end up with something that's actually viable as a product. So stick with it, I suppose.
So tell me a little about the Shuriken. What makes these bolts so special?
I guess the biggest thing is it's not really a bolt, right? It's a better way to think of it is it's a wrench. So one-time use wrench that you can install ahead of time in the shop, and it lets you bolt from one side in the field. And there are a lot of ways to make connections from one side. Welding is probably the most common, the most widely known. There are also some other products that you know uh, kind of specialized fasteners that can be installed from one side, but they tend to be somewhat complicated. Sometimes have some other drawbacks just in terms of installation. And so I think the big advantage is just the simplicity. It's as I say, it's just a wrench. You use standard bolts and standard holes, install them with standard tools. The equations that you use to analyze the connections are the standard equations. And so it lets people uh, tackle connections that they couldn't do before with bolts, but do it with all of their standard practices and workflows, materials, suppliers, etc. So I think it just fits very simply into the way people are used to doing things, and of course, does it in a cost-effective way.
Okay, so what are some current Shuriken applications now being used, and what are some additional applications yet to be used that you think could be effective?
Yeah, so I think, certainly the original application is also the one where we've seen the most adoption, which is HSS splices. Really, the goal from the beginning and still now in the long run is to get them is to see more HSS in multi-story buildings now that you don't have to worry about splices. Um, that's going to take a long time, hopefully not too long, but it's going to take a while to kind of change industry behavior, get people used to a new way of doing things. But we are seeing it a lot right now in, for example, pedestrian bridges, and other maybe smaller HSS structures, where it comes up. But the other thing that has been really cool and somewhat unexpected is just the level of creativity that we get from engineers and fabricators who see the product, and kind of have their own ideas for how to use it that I had not thought of, and that my colleagues at Atlas Tube had not thought of. And a lot of the applications which we now have incorporated into our marketing and our typical details, and that we're prepared to help people with from a technical standpoint, started off as stuff where a customer will come to us and say, "Hey, I'd like to use it for this," and we kind of go, "Wow, that is a great idea. I never thought of that." So, I expect that as we go on and more people become aware of it, having a large group of smart people with a new tool, they're undoubtedly going to come up with some cool new things that you can do with it. So we'll have to see what those end up being.
So how can engineers apply Shuriken to their work? What do they need to know to be able to work them into their designs?
Yeah, I think the biggest thing is, if you're an engineer and you're designing a connection and you're tempted to specify a field weld, or if you're a fabricator and you get a set of drawings from the engineer that already has the field weld specified in there, that's kind of an alert that there may be a way to do it without the welding with Shuriken. Um, so, certainly, again, the HSS splices, that's the bread and butter. If you have to do that, by all, this is definitely the way to go, unless it's, maybe a very architecturally um, critical spot where it has to be completely smooth. But in general, if you can't reach it, not being able to reach something is probably the most common reason for welding it. And so, um, anytime you find yourself tempted to do that, it's worth taking, 30 seconds to step back and uh, see if Shuriken might get you out of that problem.
So can you describe one or a couple unexpected outcomes from inventing Shuriken? Something you didn't see happening?
Honestly, that it worked. uh, at the very beginning, it was kind of like, well, this is a long shot, but it'd be a shame to have an idea and not at least try. Again, I had the time, so um, you know, starting out, I figured I'd try to patent it, and I kind of told my wife, like, I have to hire a patent attorney, and just please understand this is probably not coming back. But you just kind of kept taking each step, and to my surprise, the next step kind of opened up. So yeah, just the fact that it caught on, and was able to kind of find a home with Atlas Tube, where it could really kind of get the development and the investment that it deserved, was a huge surprise to me. So yeah, the fact that we're sitting here today is very surprising.
So what are you working on now? You're with Atlas Tube, but what are you doing for them, and what are you working on new products, new inventions?
Right now, the priority is really to fill out the Shuriken line. So when I originally um, did the development, it was just for one size of bolt. And in the industry, there are maybe four, maybe as many as six sizes that you see with some frequency. So we're just trying to fill out the Shuriken line so that it can um, accommodate all of the industry standard hardware, and that's fairly there's design and testing and tooling up and all that stuff. So that is certainly most of my time. And aside from that, it's again, the original goal was to get people to use more HSS in their building design, and that kind of remains the long-term goal. Certainly, obviously for Atlas Tube and for me as well. And so part of uh, the goal from here on out is to kind of use Shuriken as a hook or as leverage to kind of get people to uh, look at steel construction a little bit differently than we're used to, and being involved with how we get that message across to engineers is probably the biggest focus at the moment.